Welcome to Architect of Tomorrow. We don't just write code here, we design the systems that run the world.
Welcome to the Deep Dive, the show engineered to take your comprehensive source material, all the research, all the articles, all the notes, and distill it into the essential knowledge you need right now.
Today, we are diving deep into one of the most intellectually demanding and, frankly, economically rewarding professions out there, the architect.
Right. But as our source material makes very clear right from the jump, we're talking about a title that means two wildly different things now.
Exactly. You've got the architect of physical structures on one hand and the architect of these incredibly complex technology systems on the other. Equally essential, but, completely different jobs.
That's the core tension we're exploring today. Our mission is to synthesize that entire landscape for you. We're going to map out the career tracks, break down the global compensation benchmarks, and really get into this monumental shift in thinking that's required to pivot from being, say, an engineer to a true architect.
And we absolutely cannot ignore the elephant in the room.
Yeah.
AI. We're going to analyze how these emerging technologies are fundamentally changing the very definition of design and, maybe more importantly, the economic value of the human at the center of it all.
Let's start with that economic hook, because the numbers themselves tell a really compelling story about a massive shift toward digital complexity.
They really do.
When you look at the compensation data from around the globe, traditional architects, they command very high salaries. The data shows senior architects in a place like the UAE can pull in up to $180,000.
Which is a fantastic salary. But, and this is the key, the specialized technology architects, particularly in these high-demand fields of the U.S., they often blow right past those figures.
By a lot.
Yeah, by a substantial margin. A solutions architect in the U.S., for example, is averaging around $209,000. And that's not just a pay gap, it signals a profound economic redirection.
So what is the market valuing there?
It's valuing the ability to design, to govern, and to maintain coherence across these vast, sprawling digital infrastructures. That strategic digital vision is incredibly scarce. And that scarcity is driving the price sky high.
Okay, so let's unpack this whole thing, starting with the role we all think of first.
Yeah.
The traditional physical architect. This is the person responsible for the built world, right?
Right. They're combining this deep artistic vision with some really essential technical expertise to design and plan the buildings and structures all around us.
They're basically the guardians of our physical legacy.
That's a great way to put it. When you look back through history, their work defines entire eras. The sources bring up these incredible examples like Le Corbusier's city plan for Chandigarh, a total expression of modern urbanism.
Or something even more ancient, like the Taj Mahal.
Exactly. A structural marvel that came from this profound architectural vision and, incredible technical skill. The output is tangible. It's permanent.
So for anyone listening who is thinking about that path, the roadmap to get there is, it's incredibly rigorous and very clearly defined.
Oh, it's a marathon. You first have to get a professional degree, a bachelor or master of architecture. And then the really grueling part begins.
The internship.
A structured internship, often for several years. And then you have to pass this comprehensive multi-part exam, the Architect Registration Examination, the ARE.
And only after jumping through all those hoops can you actually get your state license and practice on your own.
Right. It's a system built to ensure public safety, to maintain really high standards. It demands just a huge commitment from anyone entering the field.
And once you're licensed, where's the money? The global market is always buzzing with urbanization and infrastructure needs, but compensation seems really sensitive to local economies.
It's very sensitive. Based on average salaries for, let's say, mid-career architects, the Netherlands actually reports one of the top averages. It's about 66,000 euros.
Which, with the conversion our sources used, is about, $73,000 US dollars?
Yeah, around $72,445. It's a respectable living, for sure, but it's really just the starting point when you start comparing globally.
This is where it gets really interesting with the senior people. The senior or principal architects, the ones with a decade or more of experience.
They're in a completely different ballpark.
So in the United States, that range for top roles, you're looking at between $110,000 and $160,000.
And Australia is pretty similar, mirroring that at around 120 to 160K in US dollars. And then you have the UAE, which we mentioned as this kind of global outlier.
Where specialized senior roles can go all the way up to 180,000.
Right, which just reflects the insane pace of all the mega project development happening there.
We should also pause, though, and look at the huge variation inside some of these big developing economies. India is a perfect example.
Oh, absolutely. The city-to-city difference is just striking. You take a city like Pune, for example. It's got this thriving, concentrated architectural and IT industry. So the average salaries are up around 14.7 lakhs per annum.
Okay, let's give that some context. A lakh is 100,000 Indian rupees, so 14.7 LPA is about 17 or 18,000 US dollars a year. But the key is how that compares to other big cities, right?
Precisely. If you contrast Pune with a city like Chennai, the average salary is way lower, around 7.6 LPA. And this gap isn't random at all.
It's about demand.
It's about the cost of talent, the sheer volume of high-value commercial projects, and the overall infrastructure investment that's driving demand in certain hubs over others. Plus, specializing matters hugely. Commercial architects can make a lot more, maybe up to 24 LPA, compared to someone just doing residential projects.
So you have these massive economic pockets even within the same country.
Exactly. It creates this huge internal stratification.
Okay, so beyond location and experience, the sources point to one massive trend that's just reshaping everything in physical architecture.
Sustainability.
The sustainability imperative.
It's not a niche anymore. It's just a fundamental shift in what clients are demanding. The whole sustainable architecture sector is predicted to grow at a compound annual growth rate, a CGR of 7.5% through 2028.
And that's because, what, something like 72% of firms are saying their clients are making this a top priority.
A top non-negotiable priority. And the demand for the actual green buildings is growing even faster, something like 14.3% growth projected through 2027. This isn't just about looking eco-friendly.
It's about real metrics.
It's about optimizing for energy efficiency, waste reduction, material sourcing. It's driven by new regulations and what the market expects now. Architects with certifications like LE accreditation have a huge competitive advantage.
Before we pivot to the digital world, we should touch on the business structure of this industry, at least in the U.S. It's surprisingly fragmented.
It's incredibly fragmented. The research shows there are over 73,000 architectural businesses in the U.S.
73,000? That sounds enormous.
It does, but the vast majority are tiny. A staggering 91% of all these firms have fewer than 19 employees, and 3/4 of them have 5 or fewer.
So it's an industry of small shops.
It really is. The average firm size is only about 3 people. It's built on these small, specialized practices, but that creates this curious power dynamic.
With the big firms.
Yeah, the minority of large firms, the ones with 50 or more employees, they represent over half of all private practice employment and nearly half of the industry's total revenue.
So while most architects are in these small boutique settings, it's the big established players who really dictate the market, who set the standards, and who get the biggest projects.
For sure. For a young architect who wants that broad experience, landing a role in one of those big firms can be a massive career accelerator.
Okay, so that's the established world. Licensed, fragmented, driven by permanent structures, and now sustainability. Let's pivot now to the digital architect. It's a completely different universe.
Right, so in the tech world, you don't just, graduate from university and apply to be an architect. It's almost always a promotion from within, right?
Yeah.
A conscious pivot.
This is maybe the single most crucial distinction in our entire deep dive. The title change from engineer to architect is, while it's superficial, the real change is a fundamental transformation in how you think professionally.
We're talking about moving from being tactical to being strategic.
Exactly. If you're a developer, your focus is, and has to be, tactical. Immediate requirements, implementation details, making sure the code actually works, shipping the feature that's due today. Your time horizon is short. It's the current sprint.
But the architect have to operate on a completely different timeline.
A multi-year horizon. Their focus is strategic. It's on high-level design principles, system-wide concerns, and managing all the inevitable trade-offs. And this means they have to grapple really intensely with NFRs. Okay, let's stop there. For anyone listening who doesn't live in a world of acronyms, what are NFRs and why are they so central to the architect's job?
Right, so NFRs are non-functional requirements. They're the qualities a system must have. It's not about what the system does, the features, but how well it does it.
So things like speed, security.
Exactly. We're talking about scalability, security, performance, maintainability, resilience. A developer implements a feature. The architect makes sure that feature can survive a massive traffic spike, is protected from hackers, and can still be maintained by a new team 5 years from now. The NFRs are the constraints that shape the entire design.
And that leads directly to this phrase, our source material uses, that I just love. Temporal thinking.
It's the perfect phrase, isn't it?
Yeah.
It captures the mindset shift perfectly.
It really does.
The architect has to shift their internal question from, how do I write this specific piece of code well today, to how do I design an entire system that not only works now, but can also survive, adapt, and evolve gracefully as the business changes over the next 5 to 10 years.
So they're prioritizing long-term health, long-term architectural fitness, even if it's harder in the short term.
Even if it means more upfront work. Absolutely.
But hold on a second. If the job is all about strategic judgment and this high-level long-term design, why is it so essential for them to have, 5 to 10 years of intense hands-on programming experience? Couldn't a really sharp analytical manager step into this role?
That's a great question, and it's a fair challenge. But the sources are absolutely definitive on this. That deep technical background is a prerequisite. It's not a nice to have.
And why is that?
2 huge reasons. First is just technical feasibility. An architect who hasn't actually wrestled with code, who hasn't spent nights debugging, can dream up an elegant design that is completely impossible to build. You need that deep expertise to ground your choices in reality.
Okay, that makes sense. And the second reason, I'm guessing, has to do with leading the team.
You nailed it. It's all about respect and authority. When an architect dictates a complex pattern, like using microservices, the development team has to trust that the architect actually understands the pain points and the challenges of implementing that.
If you haven't been in the trenches, you can't lead the troops.
You really can't. You won't earn the respect you need to guide a team of high-performing senior developers. The data shows these top architect roles often require more than 11 years of experience. That technical mastery is the foundation you build the strategy on top of.
So with that foundation in place, what are the core responsibilities that define their day-to-day life?
First and foremost, the architect is the integrator. They're the glue that holds everything together. They're responsible for making sure that all the individual project strategies across different teams actually integrate seamlessly.
So if one team is using AWS and another is on Azure,
The architect is the one who defines the rules for how those two clouds are going to talk to each other to serve the business. It's their job.
and second, they're a communication bridge. They spend more time talking than coding.
A lot more time.
Yeah.
They're constantly interacting with high-level stakeholders, VPs, product owners, clients. They have to translate these fuzzy business goals, like we need to grow market share by 20%, into concrete technical solutions and design choices.
Which also makes them technical leaders and mentors for the dev teams.
Yes, they provide critical guidance, they promote best practices, they enforce the design governance. They're teaching the developers how to build the thing they designed.
And finally, their whole job is just a series of high-stakes decisions and trade-offs.
And these decisions are weighty because they have these huge, far-reaching consequences. Think about the level of decision we're talking about.
It's not choosing a variable name.
No, it's choosing between a relational database and a NoSQL database based on the next 5 years of the company's data strategy. It's deciding between shipping something fast today versus the long-term cost of maintaining proper security. They solve the big, complex problems where there's almost never one obvious right answer. Every choice is a sacrifice.
Okay, so the word architect in the tech world is just too broad on its own. To really get it, you have to understand the hierarchy, right? The taxonomy of different specializations.
Absolutely. Our sources do a great job of breaking this down based on organizational scope, so moving from the biggest, broadest view down to the really deep technical stuff.
So where do we start? At the highest level?
At the very top, the 30,000-foot view across the entire organization's technology landscape, that's where you find the enterprise architect, or EA.
The EA has the broadest and longest-term view. They're looking at everything: software, hardware, processes, to make sure it all aligns with the company's big picture vision and business goals.
They're like the master city planners of the digital world. They're defining the zoning laws, the major infrastructure, the high-level rules of the road.
And to do that, they often need expertise in these formal frameworks, like TOGF.
Right, TOGF, the Open Group Architecture Framework, it's this comprehensive, structured approach for managing a whole enterprise's technology. It helps the EA make sure all the tech investments actually deliver business value and, fit together coherently.
Okay, so moving down a level, but still looking across multiple systems, we find the role that's often the highest paid, the solutions architect.
The Soleil. This role is the vital bridge between a specific business problem and a viable technical solution. So if the business says, we need a new customer portal, the solutions architect is the one who designs the entire system to deliver that.
And they're working across a whole suite of different applications and infrastructure parts.
Exactly, and that's why they get paid so much. They need this really broad, multidisciplinary knowledge. They have to be fluent in security, networking, databases, integration. Their whole job is to take a complex business need and translate it into a robust, scalable solution.
And the research shows that without them, big IT projects are much more likely to fail.
Substantially more likely. They're the critical intermediary.
So if the solutions architect is the city builder, then the next one down, the application architect, is more like the building's internal designer.
That's a perfect analogy.
Mm-hmm.
The APA focuses intensely on the deep technical vision and the internal structure of one single large, complex application.
This is where the real nitty-gritty details matter.
A ton. The application architect is the one selecting the underlying patterns, deciding if the system should be a big monolith or broken up into microservices. They need profound, deep knowledge of specific programming languages and platforms. Their decisions directly impact how well that one application performs and how easy it is to maintain.
And finally, at the most granular level, we have the technical architect.
Right. You zoom in even further. This role is focused on very specific implementation details, often tied to a single product or platform, like SAP. They define the technical guidelines for that one thing, and they need incredibly deep domain expertise to do it.
Okay, so that's the hierarchy. But let's talk market dynamics. Where is the real demand, the high-value compensation right now?
It's all in these modern, high-demand specializations that are driving all the digital transformation projects.
And the first one is pretty obvious, the cloud architect.
You have to have one. They are the indispensable designers and managers of the company's infrastructure on platforms like AWS, Azure, or Google Cloud. Their focus is laser-sharp on scalability, security, and maybe most critically, cost-effectiveness.
Because that cloud bill can get huge fast.
It's often the single biggest line item for a modern tech company. And this is where the role blurs a bit with engineering. A cloud architect has to be able to code. They need to be good at automation and infrastructure as code IAC, using tools like Terraform. They're not just drawing diagrams, they're writing the code that builds the infrastructure.
And the market quantifies this value very, very clearly. A Google Cloud Architect certification is linked to average salaries over $190,000.
And the AWS equivalent is up there too, nearly $156,000. These certifications validate skills the market is willing to pay a massive premium for right now.
Okay, next up is a role that's just become mission critical as everything becomes more decentralized. The integration architect.
The master connector. As every company breaks down their old applications into microservices or uses multiple clouds or relies on all these different SaaS platforms, someone has to make sure they can all talk to each other.
That's the integration architect.
That's their entire job. And it requires expertise in these really complex patterns like event-driven architecture or EDA.
So instead of one system directly calling another.
It's like one system publishes a notification, an event, and any other system that cares can subscribe to it. It's like switching from direct phone calls to a company-wide broadcast feed. It decouples everything, which makes the whole landscape more resilient and scalable.
And the financial forecast for this role is pretty strong, right?
Very strong. The estimated salary growth potential is expected to jump by 13% over the next 5 years. That's a direct reflection of the market realizing that managing the complexity between systems is a huge strategic need.
And finally, the newest high-demand role, born from the current tech revolution, the AI architect.
This is a really interesting blend of data science and systems architecture. The AI architect is responsible for integrating these advanced AI capabilities, like machine learning, into the company's existing IT infrastructure.
So their job isn't to train the models themselves.
No, not usually. Their job is to design the pipelines and the governance that allow those models to run reliably, securely, and at scale within the rest of the system. The urgency to get this right is just massive, especially when you see projections that AI could add, $15.7 trillion to the global economy by 2030? The AI architect is building the plumbing for that new economy.
So we've mapped out these two different worlds, but now they're both getting hit by the exact same disruptive force: artificial intelligence.
And it's having a fundamental impact on the architect's workflow. It's moving way beyond just simple automation and actually starting to augment the creative design process itself.
In software architecture, the sources describe AI as acting like an incredibly sophisticated sparring partner.
It's a great analogy. It helps the human architect by taking a huge, complex problem and breaking it down into smaller, more manageable pieces. And then it can recommend optimal architectural patterns based on historical data.
So it might suggest, say, a microservices approach over a monolith for a new project based on the projected growth.
Exactly. And beyond that, the AI tools are getting really good at risk assessment. They can scan a proposed design or a code base and quickly flag potential bottlenecks or security vulnerabilities that a human might easily miss.
And I imagine it's a huge help with documentation, which is the part nobody likes to do.
Oh, a massive help. You can support completeness checks, review documents, and ensure that what's described actually matches what was built. It saves countless hours and improves accuracy.
And we're seeing a similar revolution in physical architecture with something called generative design.
Right. This is where AI tools let an architect input a bunch of constraints: budget, materials, square footage, environmental factors, and the AI will then spit out hundreds, even thousands of different design alternatives.
All optimized for those parameters.
All optimized for things like minimizing structural materials or maximizing natural light. It gives the architect this incredible menu of optimized blueprints to choose from.
And the data backs this up. Something like 57% of physical architects expect to be using AI for sustainability analysis in the next couple of years.
It's clearly where the whole profession is headed, which raises this immediate and kind of philosophical question.
If the AI can handle the synthesis, the modeling, the documentation, what is the irreplaceable job of the human architect?
The sources are very clear on this. The human's value shifts entirely to strategic judgment. The AI provides the menu of options, but the human has to be the one to select, to refine, and to apply creative, strategic, and frankly political judgment to the final choice.
So the human provides the context and manages the client relationship.
And makes the final call based on human-centric goals that a machine just can't fully grasp yet.
But this reliance on these evolving intelligent services introduces a brand new architectural challenge, doesn't it? This risk of volatility.
This is a fascinating problem. If you build your application to rely on a third-party AI service, like a facial recognition API, you have to remember that its internal model is constantly changing. It's a black box that evolves without telling you.
So the service could start giving you different results for the same input, and you'd have no idea.
Exactly. The confidence level it returns might drop, or it might start classifying things differently. And that could silently break the safety or robustness of your application.
So what's the architectural solution to that?
The sources propose a really ingenious strategy. You implement a proxy server that sits between your application and that intelligent service. And that proxy uses what's called an application-specific benchmark data set.
Okay, so how does that work in practice?
You basically feed this specific known set of data points that are critical for your application to the intelligence service through the proxy over and over again. The proxy monitors the responses.
And you set a tolerance threshold.
Right. If the service's behavior changes beyond that threshold, if the confidence score for a known image suddenly tanks, or it changes the labels it returns, the proxy detects that drift.
It's like a sentinel watching for any changes that actually matter to your application.
Precisely. And instead of just letting that change silently break your app, the proxy can intercept it and throw a specific error code back to your application.
So your app can then handle the change gracefully instead of just failing unexpectedly.
It ensures you maintain your quality attributes, rather than just blindly trusting this unpredictable black box.
This massive increase in efficiency from AI also seems to strike right at the heart of the business model for architects. The whole idea of billing by the hour seems broken.
It's quickly becoming obsolete. If an architect can use AI to do a design in 10 hours that used to take 100, billing for time actually penalizes them for being more innovative and efficient.
So a client would pay less for a better, faster, more optimized design. It makes no sense.
It makes no sense at all. The emerging model is what's called value pricing. The compensation shifts to being based entirely on the strategic impact, the quality, and the innovation of the outcome, completely regardless of the hours spent.
So you're paying for the insight and the result, not the labor.
Exactly. There's a huge fundamental shift in how architectural services are going to be bought and sold.
So we've established that the architect is no longer just a coder or a draftsman. They are strategic decision makers, bridging technology and business. But to succeed in that role, you need more than just technical brilliance, right? You need mastery of social dynamics.
100%. Success in architecture, whether it's software or physical, is fundamentally tied to communication and collaboration. The architect is constantly making these decisions that have huge downstream consequences for the business.
And our sources have some really interesting insights into how they do this, specifically focusing on the humble whiteboard meeting.
The whiteboard meeting is the crucible of architectural thought. When you ask architects why they hold these meetings, the top reasons are always brainstorming, both their own ideas and pulling in ideas from others, understanding the really complex parts of a problem, and, clearly explaining how the system is supposed to work.
It's a tool for shared understanding.
An essential tool. And these meetings are where the big decisions are debated, but the decision-making process itself is really difficult, precisely because of all those dependencies and consequences we talked about.
So architects have to choose between different styles for making a decision.
Right. They're constantly balancing two things. On one hand, you have the architect-driven styles, the authoritative approach where the architect just makes the call, it saves time, it's clear.
But on the other hand, you have the more collaborative, consensus-driven styles.
Exactly. And that approach, while it definitely takes longer and you can run into disagreements, the sources suggest it's often favored for very good reason.
And what's that?
Because it massively increases the team's motivation and buy-in. It promotes continuous knowledge sharing, and it's incredibly effective at uncovering hidden expertise on the team that the architect might not have even known was there.
So you're trading speed for better team engagement and potentially a better outcome.
That's the trade-off.
Which brings up team composition. It sounds like having a team of only senior experienced architects might not actually be the best idea.
It might even be detrimental. The sources strongly advocate for mixed teams, with both novices and experienced architects and developers.
Why is that mix so important?
A few reasons. It's great for education. It provides a diversity of expertise, but most importantly, it helps the team avoid getting fixated on past solutions. An experienced architect might default to what worked 5 years ago, but a novice often brings fresh knowledge of new technologies that can solve the problem better today.
Okay, let's pivot one last time to the learning mandate. With tech evolving so fast, multi-cloud, AI, new security threats, and architect skills can become outdated in months, not years.
Continuous upskilling isn't just optional, it's the very definition of the job. And this brings us directly to the principles of andragogy.
Okay, andragogy, that's a big word. What does that mean for an architect who's just trying to keep up?
It's just the formal theory of adult learning. And the core idea is that adults learn very differently from children. They're self-directed, they bring a ton of prior experience with them, and they learn best when they know exactly why they're learning something.
So for training to actually work for a busy architect, it has to be practical.
It has to meet 4 key criteria. It has to align directly with their professional goals. It has to use and build on their past experience. It has to be focused on real-world problems, not abstract theory. And it has to be immediately applicable. The adult learner is always asking, what problem does this solve for me right now?
So how do you actually do that? How do you train an architect on something as complex as multi-cloud governance using these principles?
The effective methods are all practical. You provide robust, self-guided learning experiences. You create training materials that are informed by direct feedback from their managers, so it's relevant. And critically, you offer safe practice environments.
A sandbox, basically. A simulation where they can't break anything.
Exactly. A sandbox is indispensable when the stakes are this high.
It seems like the ultimate tool for getting proficient quickly.
It really is.
Yeah.
Giving adult learners a risk-free environment to experiment, to make mistakes, and to apply new knowledge on complex systems, well, it builds deep confidence and practical skill faster than any lecture or textbook ever could. It's the only sustainable competitive advantage when your technical expertise is so perishable. Hashtag tag outro.
This has been a truly expansive deep dive into the world of the architect. We started by mapping out these 2 highly complex professions that share one single title.
We detailed the structured, globally compensated career path of the physical architect, and we showed how sustainability has become this non-negotiable driver in that market.
And we broke down that fundamental pivot required for the technology architect, that shift from being a tactical coder to a strategic, visionary thinker.
Right. And we dissected that whole taxonomy, proving that specialization, especially in fields like cloud and integration architecture, is being rewarded with average compensation in the U.S., well over $200,000.
We also analyze how AI is augmenting the entire design process, shifting the architect's value from billing for hours to providing strategic judgment.
And we underscored that the only way to succeed long-term is through continuous relevant learning that's aligned with those rigorous principles of adult education, of andragogy.
At the end of the day, it seems the role of the architect, whether they're designing a city for millions or a multi-cloud system for a global company, is always about one thing.
It's about managing complexity and defining coherence in the face of volatility. That mandate is absolutely timeless.
But let's leave you with one final thought to mull over, based on all the challenges we've discussed today. We know that software systems inevitably suffer from decay and erosion over time, right? Requirements change, new tech comes along.
That's a constant battle against entropy.
Exactly. And as AI accelerates these technology cycles, making it faster and easier to spin up new solutions and retire old ones, it raises a really important question.
And the question is this: will the true measure of the architect of the future be defined not by the systems they design to last, to endure for 20 years, but by the systems they design to be most easily and affordably retired and replaced?
So are we designing for planned obsolescence, focusing on modularity and easy replacement instead of permanence?
It's a complete inversion of how we've traditionally thought about design, isn't it?
Yep.
Something to think about.